This is section 1.5, angle relationships. There are many different angle relationships in geometry, and this section will explore all of them. Alright, so a couple key concepts here. Three special angle pairs, adjacent angles, linear pairs, and vertical angles. Adjacent angles, those are two angles that lie in the same plane and have a common vertex and common side, but have no common interior points. So if we look here at our examples, angle 1 and 2 are adjacent angles. Angles 1 and 2, they share this vertex right here, and they share this side here. Likewise, over in this diagram, angles 1 and 2 are adjacent because they have a common endpoint, or a common vertex, and a common side. Non-examples here, angle 3 and angle ABC are non-adjacent angles. Angle 3 here is formed by these two rays here. They meet at this vertex B here. And angle ABC is a larger angle. Yes, it is true that angle 3 and angle ABC have the same vertex and share a side, but in this case, angle ABC has an interior point right here. And the big thing is that adjacent angles can't have any common interior points. Same thing here with angle 3 and angle ABC. First off, they don't even have the same vertex. So when you think of adjacent angles, think common vertex and common side. Linear pairs are pairs of adjacent angles with non-common sides that are opposite rays. I kind of alluded to this back in the last section, and I said if two rays are opposite rays, then they form something called a straight angle, and straight angles have a measure that is 180 degrees. That's certainly going to come into play in this section here. So examples here, let me erase this for us. Alright, angles 1 and 2 here are a linear pair in the diagram because their non-common sides are opposite rays. Over here, non-example, angle ABD, or angle ADB, and angle ADC. They are not linear pairs because the non-common sides do not form opposite rays. And then vertical angles are two non-adjacent angles formed by two intersecting lines. Examples here are angles 1 and 2. Basically, when you see the word vertical angles, think of the first letter in vertical. They make V's almost. Okay? So in this case, these two angles here are vertical, and these two angles here are vertical. Angles 1 and 2 and angles 3 and 4. You'll find that as we do this, as we go through the course, and that vertical angles are always going to be congruent. So in this case, angles 1 and 2 are congruent, and angles 3 and 4 are congruent as well. And here's some non-examples. Angle AEB right here, and angle DEC right here. First off, this line, this is a ray here from E in the direction of B, and this is another ray. They do not form a line. They are not opposite rays, and they're not lines for that matter. Other angle repair relationships, I alluded to it earlier in the last slide here. Vertical angles are congruent. So that means angle ABC and angle DBE are congruent, and angle ABD and angle CBE are congruent. Alright. Three more concepts about angle relationships. Complementary angles, those are two angles that whose measures have a sum of 90 degrees. Supplementary angles are two angles who have measures that have a sum of 180 degrees. The way I remember this, think about the alphabet. C comes before S in the alphabet. 90 is less than 180. So complementary angles have a sum their measures sum to 90 degrees. Supplementary angles are angles whose measures sum to 180 degrees. And you can see here in the diagram that's given, angle A and angle B are 65 degrees and 25 degrees respectively. 65 plus 25 equals 90. Similarly, for supplementary angles, angles Q and P here have measures 120 degrees and 60 degrees respectively. So 120 degrees plus 60 degrees equals 180 degrees. And then talking about linear pairs, again, the angles in a linear pair are supplementary. And that's only because opposite rays here, these opposite rays here, form a straight angle, and straight angles have a measure of 180 degrees. Okay? Alright. Another concept in this section is perpendicular lines. Perpendicular lines intersect to form 4 right angles. So the measure of that angle there is 90 degrees. The perpendicular lines intersect to form 4 congruent adjacent angles. So all of these angles here are 90 degrees or right angles. They're all congruent. This angle right here, all 4 of these angles are congruent and they're also adjacent. They share a common side. A couple other things here. Segments and rays can be perpendicular to lines or other line segments and rays. And the right angle symbol in the figure indicates that the lines are perpendicular. Again, this symbol right there. Right? And the way we label or denote perpendicular lines is by using this little upside down T, and that's read is perpendicular to. And in the diagram here, since we have one right angle here forming these 2 lines here, lines AD and lines BC intersect to form a right angle, we say line AD is perpendicular to line CB. Alright, so that's pretty much the big chunk of the concepts for this section. One other part that we need to discuss is the fact that in geometry, some figures and sketches are used to depict a situation. They may not reflect total accuracy. Certain relationships you can assume to be true, but others you cannot. And basically, I'm going to give you a diagram here on how to interpret these diagrams, on what you can assume versus what you cannot assume. In this diagram here, things that you can assume is that all of these points are coplanar. You can assume that points G, H, and J are collinear. You could assume that these 4 rays HM, HL, HK, and line GJ intersect at point H. You could say point H is between G and J. That's section 1.2 when we talked about betweenness of points. We can assume that point L here is in the interior of angle MHK because this right here is the interior of that angle. We could also assume, let me erase that. We could also assume a few more things. We could also assume things are true about adjacent angles, such as angle GHM and angle MHL. You could assume things are linear pairs, and you can assume certain angles are supplementary here. So you can assume a fair amount from this diagram here. But for everything that you can assume, these are some things that you cannot assume. You can't assume that ray HM is perpendicular to ray HL. You cannot assume that to be true, even though it looks it. We can't say it's true unless we have definitive knowledge of that. You cannot assume that these 3 angle pairs are congruent, such as angle JHK and angle GHM. And similarly for these angle pairs, we can't assume they're true. Nor can we assume that these 4 segment pairs are congruent. such as GH and HJ, HJ and HK. We cannot assume that. We actually would have to show that to be true. Okay, so just be cognizant of the definitions and everything that we've talked about so far in terms of what you can assume versus what you cannot assume. I know on the test that I just gave, there was one particular question where the angle measured 100 degrees, but the diagram looked as if it was an acute angle, and I told some of my classes, I forgot, and a couple of the others, that it wasn't drawn to scale. So yeah, some things you can assume versus some things you cannot assume. All right, some examples here. Number one, name two acute vertical angles here. All right, so acute, we're looking for something that measures between 0 degrees and 90 degrees. So let's look here. Well, we have a 30 degree angle here, right? Angle BAC. Vertical angles, think they form a V. Well, we're looking, do lines CF and line BE intersect? Well, yeah, they do. They intersect at A, and they form these angles right here. Angle BAC and angle FAE. They are congruent, and they are vertical. So one angle pair there is angle BAC, and that's congruent to angle FAE. There's another angle pair as well that that's both vertical and acute. That would be angle CAD and angle NAF, or angle FAN, because they are 55 degrees respectively. All right. Linear pairs. Linear pairs, remember, those are angles. They're adjacent angles whose non-common sides are opposite rays. They also have a sum of 180 degrees. So we basically can take any line here and we could find a linear pair here. Let's look at this line right here, line DAN, or line D, DN. All right. We could take any ray here from point A, such as ray AC, and we have a linear pair. We could say angle DAC. All right. That's, let me put it in a different color here. Let me put it in, let's say, green here. This angle right here, angle DAC, right? And then we can say another angle, let's put this one in a light blue here, an angle CAN, right? Their non-common sides are opposite rays, and they share a vertex and a common side. So angle DAC and angle CAN are linear pairs, and it's also true that the measure of angle DAC plus the measure of angle CAN is 180 degrees. Okay. Third example, find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. So we have two angles, and they're supplementary. So let's denote these two angles as, say, angle 1 and angle 2. All right, and we're going to figure out what their measures are based off the diagram, based off the information we're given. Okay? Well, we know that since they're supplementary, their measures have to have a sum of 180 degrees. If the problem said two complementary, then this value would be 90 degrees. All right? One angle, what we're going to do here is we're going to assume that it is x degrees. The other angle is 6 degrees less than, so a minus 6, 6 less than 5 times the measure of the other angle. So 5 times the measure of the other angle, angle 1, is x. So the first angle has a measure of x, and then the second measure is 6 less than 5 times the measure of the first angle, or of the other angle. And now we can take and substitute both of these into our equation here and solve for x. So the measure of angle 1 is x, the measure of angle 2 is 5x minus 6 equals 180. And we'll solve this equation. So we get 6x minus 6 equals 180. Add 6 to both sides. We get 6x equals 186. Divide by 6 and we get x to be 31. At this point, we are not 100% done yet, because we are asked to find, in the problem we're asked to find the measure of 2 supplementary angles. Okay, so we actually have to take x equals 31 and substitute them back into the measure of angle 1 and angle 2. So the measure of angle 1, which is x degrees, is 31 degrees. And then the measure of angle 2 is 5 times 31 minus 6. 5 times 31 is 155 minus 6, which is 149 degrees. Okay. Once you basically get one of these angle measures here, once you get the measure of any one of these, you could in essence say, since we know the measure of angle 1 is 31 degrees, it's just x degrees, we could take that to find the measure of angle 2, and because they're supplementary, we subtract 31 from 180 degrees, and we would get 149 degrees. So the answer to this question through algebra and geometry, the answer to this question are 2 angle measures that are supplementary and meet that criteria, are 31 degrees and 149 degrees. And then the last example here, it says find the values of x and y that make line KO perpendicular to line HM. Well, line KO is this line right here, and line HM is that line right there. We want them to be perpendicular, so what we'll do for this problem is we will simply assume that this is true, and we will say that the measure of angle KJI plus the measure of angle IJH equals 90 degrees. Right? The measure of angle KJI is 3x plus 6. The measure of angle IJH is 9x. That equals 90. So we get 12x plus 6 equals 90. Subtract 6, we get 12x equals 84. Divide by 12, and we get x to be 7. We do a similar process to find y. We again assume that these 2 lines are perpendicular, so then the measure of angle MJO is 90 degrees. So 3y plus 6 equals 90. Solve for y, we get 3y equals 84. Subtract 6 from both sides, we get 3y equals 84. And then divide by 3, we get y to be 27. And those are our answers. Okay?